you have to train your husky lens, giving it data in the same way that you want it to find your garbage pail. So it has to be in the same light, on the same height. You have to put the camera on the car, put it close, put it far, in the same scenarios that you want it to recognize the garbage. Now let's go over the code quickly. We have our husky lens library, we have our motor pins, and they're all outputs. We have this variable object found. We're actually going to switch the husky lens. We're going to start out with object classification. And so we want, before the object is found, we're going to look for it, and then we're going to switch, once we find the object, to object tracking mode. So we start the object found as false. I'm going to skip now to the end of the code, which is where we actually had to start. First is the husky lens print function that comes with the library. But right above that is all of our driving voids. We have turn left, turn right, stop, and forward. We started by just messing around with all of these analog right values to make sure that the car actually drove forward, drove left, drove right. One of our motors was actually really out of sync, and we had to write it significantly lower than the 255, the left motor, to make it drive straight. So these are really important. This saves a lot of frustration later on when you're telling your car to drive in a certain way and it won't drive that way. A lot of it has to do with their nuances in the wheels and the cars and the motors and the tires. So focusing first on just making sure that your functions actually drive the car in that direction was really important. All right, then we have our void set up. We're turning off all the motor pins to make sure the car doesn't drive initially. Show begin. Why dot begin is because the husky lens communicates with I2C protocol. This checks that the husky lens is connected. And then we start line 43, and this is what sets the husky lens in algorithm object classification mode. A lot of people say my husky lens keeps switching modes on itself. That's because your Arduino code can actually control what mode the husky lens is in. So we're starting with object classification. The reason you need to do that is because there are different things you need to find. First, you need to find the garbage can, and then you have to find the red zone. So we're just looking for different things, and that's object classification. So while object found is false, means we haven't found the garbage can yet. So what we do is we just keep turning in a circle. We print circling, and we just keep writing the turn left function. Line 56, 57, and 58 are what check the husky lens, see if it found anything, and it fills this variable in line 59 called result ID. Every time you train the husky lens in something, it sets it up as a new ID number. So we only have one thing, the garbage can. So if the ID is number 1, then the object found is true, and we no longer keep driving in a circle looking for this thing. We stop the car, line 63, we see print found, and now we switch the husky lens to object tracking mode. The biggest difference between object classification mode and object tracking mode is that in object tracking mode, you can actually see where on the screen the object is, which is crucial to know if your car should turn left, turn right, or stop. Object classification is just looking for objects and seeing if you found object 1, object 2, or object 3. The downside to object tracking mode is you can only track one object, in our case, object 1. So while object found is true, while we found our garbage scale, lines 69, 70, 71 are the same thing. Let's see what the husky lens found. If anything at all. And then we have a series of if statements to drive our car. So first we want to make sure that we're looking at the garbage cans. That's line 73. If result ID is number 1, that was the first thing we stored. Line 74, the result.width is how big the box around your object is. And as you get closer to your object, the box gets bigger and bigger. So in our case, when the box reached a size of 200, we're about an inch or two away from our garbage pail. So if you're greater than 200, stop the husky lens. Assuming that we're less than 200, so we're still pretty far away from our garbage pail. The next two else if statements are just whether or not we should turn left or turn right, depending on where on the screen of the husky lens your object is. So if it's at pixel numbers that are less than 130, if it's on the left side of the screen, we actually mixed up our motors. You should be turning left, but we're turning right just because it was easier than rewiring the car. There's a lot of ways to change directions. You can flip the pin numbers. We don't want to mess around with the pin numbers, so we just flipped around left and right. And if it's greater than 190, it means it's on the right side of the screen. You should actually turn to the right. But in our case, turn to the left. Anywhere between 130 and 190, meaning the garbage can is relatively in front of us, we do our last if statement is move forward. Or else, meaning if we haven't found ID number 1, just stop the car. It means we're lost. We haven't found what we're looking for. Just stop. And that was our code to find the garbage pail and hone in on it. Let's see what it looks like in real life. Now the last two clips that I want to show you really helped with the husky lens. It's not a very fast camera. It's not great at catching live action. And so what I did in the code, which I didn't mention explicitly, is that for every 50 milliseconds of driving, I did 50 milliseconds of stopping. And what that does is it makes the drive very jittery, but it really slows down the speed of the car by half, so that every frame of the husky lens, you have a chance to reassess it and decide what to do. Here's what it looks like. We know this hack was a little bit harder than the students were prepared for. We didn't want to give something that was too much of a home run, but we also hope they weren't dissuaded. Definitely with a few more hours, they would have been able to progress more, but hopefully this video will show them that they were on the right path. They just need a little bit more time, and they really did a great job. Very impressive.